Okay, 7.5 again starts with a little investigation, folks. So you're going to need a ruler, you're going to need a pencil, and you can probably use a pen as well. Okay, we're going to do exactly what it says to do. You can take that one right there. It says lightly draw a quadrilateral using all the space below. Okay, so drawing a really big quadrilateral that takes up pretty much the whole bottom section. Okay?
Any shape we want?
Quadrilateral.
4 sides.
4 sides.
Okay. So any 4-sided figure I want, Mr. Lee.
I knew it said so.
Make it like somewhat normal.
Not,
Oh.
Not
Exactly square. What?
Yeah, I don't know what's happening.
You can compare and compare.
A 4-sided thing. Is that normal?
Okay, do it lightly because you're actually going to ignore this shape.
Whoa.
Oh, I did it. I don't know what I'm doing.
All right. Step 2, and you guys can follow along. If you're waiting for me, then go on to step 2. Step 2 says measure the 4 sides of the quadrilateral and mark the midpoint of each side. So I'm swapping colors. You're going to measure each side and mark the midpoint of each side.
For all sides?
All 4 sides, yeah.
Well, that one's exactly 50. That's sweet. 35. What's half of 35?
6.
Nice. That doesn't look like the middle, but the ruler says. The ruler.
The ruler.
All right. You're going to mark the midpoint of each side, label your new points E, F, G, and H. Step 3, draw line segments to join adjacent midpoints. So the only ones you're not drawing are the ones that go straight across. Okay, so basically you're drawing a new figure. You're going to join G and H. You're going to join F and G.
The way. What if they come, like, what if they're
Weird
the
there.
slightest angle? Like the way 0.5.
You need to join the midpoints of adjacent sides.
Oh, even if they're like, you're...
No.
No way.
Alright, so your diagram, if you haven't yet, you should make sure that these guys are actually midpoints. So they need to have they need to have their own hash marks for each side. So use 1, 2, 3, 1, 2, 3, and then 1, 2, 3, 4, 1, 2, 3, 4. Okay?
Oh, why do they have different?
These two are the
All
same.
equal, but
These two are the same. These two are the same. These two are the same, but none of them are necessarily equal to each other. Okay, I did that in a color that you could see more easily because that's what the rest of our activity has to do with. It says measure each side length of the smaller quadrilateral. So you formed another quadrilateral. Mine is called EFGH. I think yours is too. We're going to measure all of the side lengths, okay? You're going to get side length EF. You're going to get side length FG. you're going to get the side length for GH, and you're going to get the side length for HE.
Hands are annoying.
Yeah, I never like anything. Never fun.
Oh yeah?
Too messy.
It made a perfect square.
Sure didn't.
Mine's a perfect square.
Yours might be pretty close. Yeah.
Maybe because you did.
It could be.
Oh no.
Mine's a perfect square. I have to measure all the sides. 25. 25.
Okay, some of yours didn't quite work out because of your drawing not being that great and your measuring not being that great and your calculations not being that great. But some of them did work out. For those of you who did work out, look at your own. For those of you who didn't, look at mine. And what do you notice about the side lengths?
They're all
equal. They're double. They're double.
No,
There's
they're all
two of them
pretty
the
much
same.
equal.
There are two that are the same. Which ones?
The opposite one.
Opposite sides are the
Oh.
same length.
Would you look at that?
Now,
Have you seen that video?
what? So number 4 on your investigation says, what relationship exists between side lengths? Go ahead and write what you found out.
there's it's on
The
our
opposites
side.
are the same.
Opposite sides have the same length. All right, 5. Consider the angles in quadrilateral EFGH. What relationship exists between the angles?
They're all equal. One.
It forms a parallelogram. That's good. We're going to get to that
They're
next.
cute.
All of them?
No, two are acute and two are obtuse. Isn't it an equilateral triangle?
Opposites are obtuse.
Okay, so we're getting closer.
They're related.
They're all lines.
What else is true about angle E and angle G?
They're
Let's get out our protractor.
Same thing.
Ah,
Same.
thanks, Ronnie. Let's double check that. Okay,
They're probably not.
this guy is 111.
So I gotta say same thing.
111 for angle G, and
Oh, mine is.
111 for angle E.
Mine's blown.
Okay, so here's what you're writing. Opposite angles are equal. Opposite angles are equal. So what type of quadrilateral is EFGH if opposite side lengths are equal and opposite angles are equal?
Parallelogram.
It is a parallelogram. Parallelogram.
I thought it was a rhombus at first. Cause like
So let's add some symbols. It's close to a rhombus, but in order for it to be a rhombus, all the side lengths would have to be the same, and they're not. Okay? So this angle is the same as this angle, and this angle is the same as this angle. Okay? Now, if you drew yours correctly, does yours also look like a parallelogram?
No.
Yes.
If you drew yours correctly.
Yeah. Yes.
Okay, so do you think that this is the quadrilateral formed by joining the midpoints of any other quadrilateral? Do you think it will always be a parallelogram?
No.
Yeah.
Well, we all drew one
Sir.
different.
Oh, yeah.
We drew a different green shape, and our blue shapes were all parallelograms.
What if we
Okay.
did one like was like this?
All right, example 1, diagonals of a parallelogram. Next person who talks out of turn gets an infraction. Diagonals of a parallelogram. Show that the diagonals of a parallelogram bisect each other. What does it mean to be a diagonal?
It's a cross.
Your shape.
Yeah, just go across to the two vertices that don't already touch, that aren't already joined. Go from A to C and from D to B. Go ahead. With a ruler, draw a line from perfectly, by the way, here's a trick, guys, to drawing your line perfectly. Don't put your ruler down first. Put your pen directly in the corner, bring your ruler to your pen, and then look at where it needs to be to get directly into the opposite corner. Okay? Put your pen down in the corner, because then you'll realize your ruler's actually set back a little bit. So you set it back a little bit at the other angle.
That actually helped me.
Okay? And the question says, show that the diagonals bisect each other. What does that mean?
Divide it to.
That they're dividing each other in half. So we need to know the length of DB, and we need to see if AC actually does cut it in half. What do you think? Is it going to happen?
Yep.
So I've got DB equals 5.6. Everyone kind of got that as well? And to the middle, I've got 2.8. I'm going to call this middle point E. So DE equals 2.8. That means BE equals 2.8. Did it bisect it? Yep. Let's try the other diagonal, because they both have to be bisected in order for this to be true. So measure AC. If you're not doing this, you should be doing this. AC, I got 8.6. AC equals 8.6. And then I'm going to measure to the middle, half of that. I got, mine's not quite perfect, really, really close though. It was 4.3.
That's exactly wrong.
Yeah, I know it was actually like 4.3.5, 4.35. And measure the other side to make sure. Yep, 4.3. So CE is also 4.3. So in this parallelogram, do the diagonals bisect each other?
No.
Yes.
Yes.
They sure do. We just measured it all, so.
I like to be different.
Okay, example 2. Use a counter example. Jody conjectured that the diagonals of a parallelogram are always perpendicular to each other. So she says if you're in a parallelogram, okay, and you draw the diagonals, that these diagonals will always be perpendicular to each other. Well, was it true in the one that I drew?
Yes.
Does it look like they're perpendicular to each other?
No. Well,
Are these both 90-degree angles?
No.
No, sir.
No. Okay?
They all
So-
together, they make 180. So yes, they are.
No, they're not.
No.
No, they make 360.
Is this a 90-degree angle?
Does it matter? Yeah. No.
No.
Does
Okay,
it matter,
done.
Though?
Perpendicular. Perpendicular means
Is that word?
90-degree angle.
It does.
Actually,
Yeah.
that does mean that when it crosses that line.
Wait, is that word
Oh,
actually
boy.
supposed to mean something?
What did you
to
write? Oh, that's intersect.
Okay.
I feel like I've
Now-
actually never.
We've proven it already. We have a counter example. Emily, Jenna, Cubs. Get control of yourself. Thank you. Okay? We have a counter example already. So we can say her conjecture is not correct. Because there's one counter example. Now, she's probably thinking about a special parallelogram called a rhombus. Okay? Or a square. Okay? In both of those parallelograms, the diagonals actually do meet at a 90-degree angle. Okay? So there are parallelograms in which the diagonals meet at a 90-degree angle, but it's not every time. So by using a counter example, we have proven her conjecture to be incorrect. Good key concepts down there. There's nothing to write. It's there for you. We'll just read it together, and the diagram matches the image, okay? The diagram matches the words. Joining the midpoints of the sides of any quadrilateral will produce a parallelogram. That was the investigation that we did at the start. And then the diagonals of a parallelogram bisect each other. That was example 1. And then being able to use a counter example whenever a property or a conjecture is not true. All right? Your practice problems are on the worksheet on the next page.